Hello, this is Mr. Collier, and today we're finding the area of circles. So firstly we have a couple of simple circle area problems. Okay, we have this circle here with a radius of 8, and we're going to use the formula for the area of a circle. Area equals pi r squared to find the area of this circle. So if you're trying this problem at home, you might want to pause the video right now, try it yourself, and then watch the remainder of the video. So here we have radius equals 8 meters. So we're going to use our formula. Area equals pi times 8 is the radius squared. 8 squared is 64, so we have 64 pi square meters. That's the exact answer. You might want to use your calculator to work out an approximate decimal answer. So we're going to do 64 pi on the calculator. And we're going to get 64 pi gives us about 201.1. Okay, so we're going to have about, or approximately 201.1 square meters is the area of this circle. And the second circle, this distance is 24 meters. That's not the radius, that's the diameter. So half that distance is going to be 12 centimeters. So the radius equals 12. We use our area formula. Area equals pi times 12 squared, so area equals 144 pi square centimeters. That's the exact answer. If you're looking for a decimal approximation, we're going to use our calculator again. So we're going to do 144 times pi, and we get about 452.4 square centimeters. So that's how to find the area of these simple circles. We're going to move on to some more advanced stuff here now. We're going to find the area of these composite figures. They're made up of more than one circle or more than one different types of shapes. So in the first one, we've got a rectangle on the bottom, and then we've got a half circle on the top here. We could even label these like A1 and A2, so we can do them separately and then add them together. So obviously the area of this rectangle, area 2 is 8 times 3 equals 24 square centimeters. And then the area of 1, that's really half of a circle. Okay, that's half of a circle. So what we can do is we can multiply half times, and then we calculate the area of the circle. So the area of a circle is pi r squared. The radius in this case, well, the diameter is going to be 8. This is going to be 8, so the radius is going to be 4. Okay, so it's going to be pi times 4 squared. And then we're going to do, well, let's do half times. We're going to do the 4 squared first. You get 16 pi. Half of 16 is 8. So A1 equals 8 pi. And so we have A1 and A2. We're going to get the total area now, which is called AT. If you add A1 plus A2, you're going to have 8 pi is the area of that region, plus 24 is the area of the square region. And if you want an approximate decimal answer, we're going to use our calculator and do 8 pi plus 24. 8 pi plus 24 equals, and we get about 49.1. So this is 49.1 square centimeters is the area of that figure. Now the second figure, we're looking for the area of this green section here. Okay, this green ring here. So what we can do, and most people can see this, is you're going to get the area of the bigger circle and subtract the area of the smaller circle. Okay, so you get the area of big circle minus area of small circle to get the final answer. So let's get the area of the big circle equals, so you can see here, The diameter of the big circle is 6, so the radius is going to be 3. So it's pi times 3 squared, which equals 9 pi. The area of the small circle is, now the diameter is 3, so the radius of the small circle is going to be 1.5. So pi times 1.5. Okay? Squared. Which equals 1.5 squared is 2.25, so we're going to have 2.25 pi. And the total area, you're going to add 9 pi plus 2.25 pi equals 11.25 pi. Okay, so if you want a decimal approximation, oops, I made a tiny error here. That is going to be, actually we have to subtract. So we're going to do, the total area is 9 pi minus 2.25 pi, which equals 6.75 pi. Okay, so that's what we're going to calculate now, 6.75 pi. Okay, so we're going to do 6.75 times pi equals 21.2. So we're going to do 21.2 is the final answer. Okay, so the area here is 21.2 square centimeters. Okay, now lastly, let's take a look at this this figure. So we get the area of the shaded region, so obviously we're going to do the area of the circle minus the area of the square. Okay, now the area of the circle is, now we say AC is 4, so half of that is going to be 2. That's 2 and 2. The radius is 2, so you're going to have pi times 2 squared, which equals 4 pi. That's the area of the circle. Now the area of the square, most people believe that you're going to have to get the side length of the square in order to get the area. Here we have 2, and this is 2. So a lot of people try to get the other side by using Pythagorean theorem, then multiplying or squaring the side length. But we don't need to do that actually, because a square has 4 equal sides. Alright, so it's a special case of a kite, because the adjacent sides are congruent. A square is also a kite. So we can use the kite formula for area. In a kite, you do, to get the area, you get diagonal 1 times diagonal 2 and divide by 2. So we can also do that with a square, and so that's very useful if you don't know the side length of a square, but you know the diagonals of a square. You can easily find the area. So the diagonals of the square are both 4. So we're going to do 4 times 4 divided by 2, which equals 8. So the area of the square is actually 8. And then finally, to get the total area, we're going to add, or subtract the area of the circle, or the area of the square from the area of the circle. So we're going to do the area of the circle is 4 pi. Then we're subtracting the area of the square, which is 8. And if we need a decimal answer, let's get that with our calculator. We're going to do 4 pi minus 8 equals, so we get about 4.6. So our answer is 4.6. Any units given? No, no units given, so let's call it units squared. Final answer.